Question 26, Instrumentation Engineering Gate 2020. Consider the matrix M is equal to 1 minus 1 0, 1 minus 2 minus 1 and 0 minus 1 1. One of the eigenvectors of M is dash. 4 options are given to us. For a detailed lecture, please refer to the NPTEL video, Module 7, Lecture 26, Eigenvalues and Eigenvectors of Linear Operators, Linear Algebra by Dr. K. C. Shivakumar, Department of Mathematics, IIT Madras. Let us understand what eigenvalues and eigenvectors are and then solve this problem. Consider that we have A, which is a 3 cross 3 matrix. We have the elements like this: A1, A2, A3, B1, B2, B3, C1, C2, C3. These are the elements of the matrix A. The characteristics equation is nothing but the equation which is A minus lambda I is equal to 0. The determinant of A minus lambda I is equal to 0 forms the characteristics equation, where lambda is the eigenvalue here. If A is a 3 cross 3 matrix, then this equation will be of third degree. Similarly, if A is equal to 2 cross 2 matrix, then this equation will be of second degree. So, if there are 3 degrees, then we will have 3 eigenvalues, and for each eigenvalue we will have one eigenvector at least. Therefore, for this we will have 3 eigenvectors. Eigenvectors are the set of vectors for which the equation satisfies. With this concept in mind, we can solve this problem. The determinant of the given matrix is A minus lambda I is equal to 0. The determinant will be 1 minus lambda minus 1, 0, 1, minus 2 minus lambda, 1, 0, minus 1, 1 minus lambda. The determinant of this is the characteristic equation. The characteristic equation is equal to 1 minus lambda into minus 2 minus lambda times 1 minus lambda, plus 1 into 1 minus lambda plus 0 is equal to 0. So, if we solve this equation, we will get the values of lambda as 0, minus 1 and plus 1. These are the eigenvalues. Let us find out the eigenvectors when lambda is equal to 0. When lambda is equal to 0, the characteristic matrix becomes 1 minus 1 0, 1 minus 2 1 and 0 minus 1 1. This into x1 y1 z1 is equal to 0. This matrix x1 y1 z1 is the eigenvector that corresponds to the eigenvalue 0. So, x1 minus y1 is equal to 0, x1 minus 2y1 plus z1 is equal to 0, minus y1 plus z1 is equal to 0. Let us solve these both. We have a common term of z1 here, so let us cancel them out. When we solve both these equations, which is equation 2 and 3, x1 minus y1 is equal to 0. So, this implies that x1 is equal to y1. Let this be k. Now, let us take the first and the third equation, which says x1 minus y1 is equal to 0, and then minus y1 plus z1 is equal to 0. So, once we solve them, we get x1 minus z1 is equal to 0. So, this again implies x1 is equal to z1, which is also equal to k. Therefore, the solution for this is x1 is equal to y1 is equal to z1, which is equal to k for the lambda value 0. So, all three eigenvectors are equal. The solution set matches with the last option where x1 is equal to y1 is equal to z1. So the correct answer is option D. Thank you.